I'm Anil Kumar, and in this video, we'll discuss how to find probability using counting principles. Now, let us first summarize what we learned in the unit on counting principles. We can count the number of possibilities in a couple of different ways. One was the tree diagram, right? So one was tree diagram, which helped us in counting the number of options. One, we talked about permutations. And we also talked about combinations, right? So these were three different major groups, which helped us to count the number of options. And as it is very obvious, in probability, we need to find what are the favorable outcomes and what are total number of outcomes. So counting is very critical. Now, tree diagram examples were like when you toss a coin, you get head or tail, right? So tossing coins is kind of a tree diagram example, right? Permutations are where the order is critical, right? So if order is critical, so that is a big question. If we are thinking about order is important, the answer is yes, we do permutation. And if the answer is no, in that case, it is combination. Permutations could be written as NPR, which really means n factorial over n minus r factorial. And in combination, since the order is not important, the formula becomes n factorial divided by n minus r factorial divided by r factorial, right? So if you select r out of n, since the order is not important, so you need to divide by those combinations. That's the whole idea, right? If it is npn, we know n minus n factorial is 0. It will be n factorial. Now, let's take a few examples which can help us solve probability questions. Okay, so let's work with, let us say, 5 numbers. And we'll take very, very simple examples, since the idea is to illustrate the use of these counting principles to find probability, correct? So let's take, we are doing theoretical probability at present, tossing coins. Okay, so let's say we have 2 coins, right? So we have 2 coins, and we want to find out that what is the probability of getting at least one tail, right? So we get at least one tail. So that is what we want to find, probability of getting at least one tail. Now, if we have 2 coins, we can always make a tree diagram. So we could get either a head or a tail with 1 coin, and then if the second one is tossed, again the combination could be head or tail, right? We are saying that this coin is a fair coin, so it's 50-50 chances for each, right? So we're talking about a fair coin, right? So let me write down fair coin. That means 50-50 chances to get head or tail, right? So the second time also we get head or tail. So the combinations which we have is 2 heads, head tail, tail head, or 2 tails. Now clearly, what are total number of outcomes? Total number of outcomes for this event, we'll call this event as A. So total number of outcomes in A is 1, 2, 3, 4, right? And I'm sorry, total number of outcomes I should have written. Now let me write NA. So favorable outcomes, that is at least one tail, so that means 3, right? So it is 3. So this is favorable outcomes. Okay, let me rewrite this. Now total is how much? Total number of outcome, that is sample space, which we say represented by the letter S, is 4. And therefore the probability of this event is indeed 3 over 4, correct? So that is how you can find probability for an event using counting principles. And in this example, we took up tossing coins. Tree diagram is a good option to work with in such cases. Now for permutations, let's take a few numbers and make some question based on that. So let's take numbers, let's say 1, 2, 3, 4, 5, and 6. Let's say we got these 6 numbers with us. And what we really want to do is we want to figure out what is the probability. Let me write down the question here again. What is the probability of getting even number? So this time we're looking for probability of even number, and that is the event A for us. Okay, we say this is event, let me call this event B this time. Okay, event B is probability of getting even numbers, right? So even 6-digit number, to be very precise. So we have these 6 digits with us, 1, 2, 3, 4, 5, 6. And since we are putting numbers like 1, 2, 3 or 3, 2, 1, order is critical, right? Therefore, it's a case of permutation. Since we are looking for 6-digit numbers, the last digit or the last place value is kind of critical. We cannot place all the numbers there. It is restricted. So, which numbers can go there? 2, 4, and 6. So there are 3 numbers, 2, 4, and 6, which could go there, right? So there are only 3 ways to fill this position, right? Now, in how many ways can you fill the other positions? If you filled one position out of 6, you're left with 5 numbers, right? So let's say any one of them has been filled. So you're left with 5 numbers. You can place, so option is 5 numbers can be placed here. Once you use 2, you're left with 4, then you're left with 2, and then 1. So these are the options for you. So multiplying this, we get the favorable ways for arranging or permutation of these numbers. So we say NB for us is equal to 5 times 4 times 3 times 2 times 1, which is 5 factorial, right, times 3, right? So we could write this as, okay, now let me write this as 5 times 4 times 3 times 2 times this 3, okay? Okay, so let me draw a line here so that you don't get confused. This was the number of options we're talking for the last place. And what are the total combinations? Now in this case, the sample space, since we have 1, 2, 3, 4, 5, 6, and we are using all 6 of them, it is NPN formula kind of thing, right? I should have written 6P6, which is 6 factorial, correct? So 6 factorial comes in the denominator. Now that is, we'll write here. So the probability, 6 factorial is the total possible outcomes. Probability of event B will be favorable numbers divided by the total sample space. So the favorable outcomes are 5 times 4 times 3 times 2. We can say this is 5 factorial times 3. And the total number of options in our sample space is 6 factorial. So that leaves us with, we can just use this. 6 factorial could be written as 6 times 5 factorial, and this is 5 factorial. They cancel out, correct? And then we are left with 3 here. So that gives us, let me write down here now, 3 divided by 6 is half, okay? So the probability for this event is half, right? Now, as you see, it looks kind of obvious, right? So there could be half of the numbers are even numbers anyway. But I hope you understand, and that reinforces the concept, correct? So that's the whole idea. It's a very simple question. You could have answered even without doing all this. After seeing the result, of course, half, 50% probability of getting even, 50% probability of getting an odd number, right? That's what it is. But that's the method, and I hope this helps you to understand. Okay, now let's take up another case where we'll talk about combination. A combination, good example is always, let's say, cards, right? So we want a hand of cards in which, let us say we want three aces, right? So let's say we want three aces, okay, three aces. Three aces, and we are dealing five cards, right? So in five cards. So that is, in five cards, we want three aces. Well, now in this case, what are the total number of combinations? Now, since we have five cards in a hand, so we have five cards hand, it really doesn't matter where you put one card, right? So it's the same thing. Therefore, it's a case of combination, right? So order is not important. It's a case of combination. Now, in how many ways can you choose five cards out of a deck of 52? So the answer is, the total space will be for us, let's call this event as C, okay? Then the sample space is 52C5, right? That is the number of combinations, right? So 52C5, you can apply this formula, find this value, okay? Now, we'll find how many of these are favorable. That means we are getting three aces, right? We are getting exactly three aces out of five cards. We are not saying at least, okay? We could have said at least to make it more complicated, but we'll take that later. If I say at least, then this means we have combination for three aces or four aces, correct? So that will become at least three aces. I'm taking three aces, just three aces, right? Now these aces could be anywhere, but any three places, correct? That's what it is. So the way to select three aces will be, so three aces out of those five cards, correct? So out of those five cards, we want three aces. If we have three aces, the other two cards are different, right? They are not the three aces we're talking about, correct? So we have a combination of selecting three aces out of five, but we have to select two more cards since we have a hand of five, right? 1, 2, 3, 4, 5. So we already selected three aces. The combination is 5C3. The other two comes from 52 minus 4, because 4 are aces, correct? We don't want to choose an ace now. So 52 minus 4 is 48, right? So we get 48. This 48 we get as 52 minus 4, right? So now we are left with 48 other cards which are not aces. So out of those, we have to select or choose combination of 2. So 48C2. So that becomes the favorable for event C. Do you see that? We're calling this as event C, right? So this was event A for us, okay? This is event B for us, and this is event C for us. Normally every event is given a capital letter name, correct? So the probability of event C is really ratio of favorable to total, right? So which is kind of like this, and this is 48 C2, times 5C3. I've changed the order, but it doesn't really matter, divided by 52 C5, correct? You selected 5 of them, correct? You can apply this formula here, find the answer. You could use a calculator, find the answer. So there are so many different ways to find this particular answer. So it is 48 combination 48C2, right, which is equal to 1128. So 1128 times 5C2. So 5 combination 2 is 10 times 10 divided by 52 C5. 52 combination C5, which is a big number, 2598960, right? So you can now multiply these and divide and get the answer. So what we will do now is we'll do 1128 times 10 divided by 2598960 equals 2. So we have 47 divided by 10, 8 to 9, and in decimals it's a small number which you could write, correct? So that is how we can actually solve such a question. So let me summarize what we have learned here. To find probability, at times it is useful to use the counting principles. We could use counting principles like we learned in the previous unit, applying the tree chart or permutation or combination, and I hope this video gives you a good review. We'll follow up with some questions from the previous test papers which should help you to prepare for your own test. I'm Anil Kumar. You can always subscribe and share my videos and learn a lot. And please also don't hesitate to post questions if you need help with. Thank you and all the best.